morning, children. Welcome back to your chemistry class. So today's topic will be quantum numbers. The behavior of an electron in an atom, it is described mathematically by a wave function or orbital. Each wave function, it contains three variables and they are termed as quantum numbers. They are represented as n, l and m. Okay, each quantum number, it refers to a particular character of the electron in an atom. These quantum numbers, they describe the energy level of the orbital and also define the shape and orientation of the region in space where the electron will be found. In addition to these three numbers, there's another quantum number which is also needed, which specifies the spin of the electron about its own axis, and that is called as spin quantum number. Now you can simply understand like this: just to search a particular person in this whole world, we need to know four important facts. What are they? The country to which the person belongs to, or maybe the city in that country to which the person belongs. Then we also need to know the street in that particular city where the person is residing, and even the house number. So when you know all these things, you can very well search a particular person. Similarly, these four identification numbers, they are required so as to find out the particular electron that is present in an atom. Okay, I also mean to say that these numbers are just like the postal address of a particular electron in an atom. Thus, what is quantum numbers, or how can we define what are quantum numbers? They can be defined as a set of four identification numbers which are needed to have full information about the various electrons that are present in an atom, and to know about their location, about their energy, shape and orientation and spin are needed. Clear? Thus, what did I say about quantum numbers? I'll write it down over here, that the quantum numbers may be defined as a set of four identification numbers which are needed to have full information about the various electrons present in an atom. Is this point very clear? So in other words, we can say to know about the location, to know about the, where I said no, the full information about the various electrons present in an atom. So what is that full information? That is, where is that atom present, its location, its energy, what shape does it have, what kind of orientation does it show, what is the spin that is required, all that we come to know. So the different names given to the quantum numbers are like the different quantum numbers are, the first one is principal quantum number. Sorry. And this is represented by the alphabet small n. Then the second one is azimuthal quantum number, and the alphabet by which it is denoted, it is called as L. Okay. Then the third is, as I had told you yesterday, magnetic quantum number, represented by the alphabet small m. And the fourth one is the spin quantum number, represented by small s. Right? So now, an atomic orbital is specified by the first three quantum numbers. The first one, which is the first one? The principal quantum number, right? It is related to the orbital size and energy. What is this related to? Orbital size and energy. Okay. What is the second quantum number related to? Azimuthal quantum number. The second one, it is related to the shape. Okay. Azimuthal quantum number explains the shape of the electron, and the magnetic quantum number, it also tells us the orientation in space, explains the orientation in space. Followed the fourth one. Which is the fourth one? The spin quantum number. What does this explain us? It is the characteristic property of the electron that is present in this atomic orbital. Clear? So the electron in a particular atomic orbital, it has a quantized value of energy, and the angular momentum and the magnetic field due to orbital angular momentum, and it is due to the spin. So the various quantized values which give all the information about an electron present on a particular atomic orbital, they are termed as atomic numbers. Thus, I write down over here the various quantized values which give all information about an electron that is present on a particular atomic orbital are called quantum numbers. Right? So how can you define what is a quantum number? They may be defined as a set of four identification numbers which are needed to have full information about the various electrons present in it. The various quantized values which give all the information about this electron present on a particular atomic orbital, they are termed as the quantum numbers. I hope till here it is very clear. So let us begin to understand all these four quantum numbers, out of which today I am going to deal with only the first and the second one so that you understand it clearly. So let us begin with the first quantum number, that is the principal quantum number, represented by what alphabet? N. Okay. So it describes what? The average distance of the electron from the nucleus. Describes the average distance of the electron from the nucleus. Clear? It is designated as, I have already told you what? N. The energy of the electron and the volume of the electron cloud, they are dependent on this quantum number. What did I say? The energy of the electron, the energy of the electron and the volume of the electron cloud, it depends upon what? This all depends upon the principal quantum number, right? Theoretically, it may have all the integral values, that is from 1 to infinity, but only values from 1 to 7 has been established in the atoms of the known element so far, right? So the shells or energy shells that we call, they are designated as what? K, L, M, N and so on. So let me explain it to you like this. Value of N and the designation of the shell. How can we explain that? If the value of N is 1, then what is the shell are we talking about? We are talking about K. If the value of N is 2, we are talking about the second shell. If the value is 3, we are talking about KLM. Okay. If it is the 4, then we are talking about the N shell. If it is 5, we are talking about O shell and so on. I hope this point is clear. Next important point about this, I'm writing it down over here. Higher the value of N, greater is the distance of the shell from the nucleus. Obviously, higher the value of N, more is the distance of the atom from the shell. That means the radius also increases. So I mention it over here. Higher the value of N, greater is the distance of the shell from the nucleus. I hope you are understanding. So over here, the radius will be equal to what? N square upon Z into 0.529 Armstrong. This is the formula that we are going to use over here. Then next important point, higher the value of N, greater will be the magnitude of energy also. So higher the value of N, greater is the magnitude of energy. So what do we mean by this? That greater the energy level, greater the value of N, what will happen? Greater will be the magnitude of energy. More farther away, more energy is present over there in that particular shell. So do you remember the energy of your hydrogen atom? Energy, sorry, not of, energy for hydrogen atom, it is equal to what? Minus 1312 upon N square kilojoules per mole. This is what we had studied yesterday. Then the third important point over here. The maximum number of electrons which can be present in this principal energy shell is always equal to 2n square. Okay, the maximum number of electrons which can be present in the principal energy shell is how much? How do we denote that? With 2n square, right? So for example, try to understand over here, like first shell I'm talking about. Okay, let me talk about first shell and the second shell. So what did I say? The first shell, according to 2n square, it will have how many? 2 electrons. Okay. Then second shell will have how many? 8 electrons. Then third shell is going to have how many? 2 into 3 into 3, that is going to give you 18 electrons, and so on. Fourth shell is going to show you how many? It is going to show you 32 electrons, right? The fourth point, that is the angular momentum, can also be calculated using the principal quantum number, that is MVR, if you remember, is equal to NH upon 2 pi, where your H is the Planck's constant. Okay. The fifth point would be understood like this, that this quantum number also explains the main lines of spectrum. So I hope everything about principal quantum number is understood to you. That is, it describes what? The average distance of the electron from the nucleus. Okay. Then the energy of the electron and the volume of the electron cloud both depend upon what? The principal quantum number. And then what else did I tell you? May have all integral values from 1 to infinity, but the only values from 1 to 7, they have been established in the atoms of the known elements, right? Now look at this, how to find out the designation of each shell. So if n is 1, then the designation of the cell we are talking is K2, then L3, then M, and so on. Some important points about the principal quantum number, that higher the value of n, greater is the distance of the shell from the nucleus, that is radius will be more, can be calculated with this formula. Higher the value of n, greater will be the magnitude of energy also. But over here I have mentioned that the energy of hydrogen atom is this much. The maximum number of electrons which can be present in the principal energy should always be 2n square. So according to this formula, we find that first shell contains 2 electrons, second 8, third 18, and fourth shell contains 32 electrons. Then we also know that the angular momentum can also be calculated using the principal quantum number, that is the n shown over here. And this quantum number explains the main lines of the spectrum. I hope the principal quantum number is very well understood by you. Now we move to the next one. Second quantum number, that is Azimuthal quantum number. This is also called as subsidiary quantum number. Okay. What is the alphabet it is represented with? It is represented with a small n. So what does this azimuthal quantum number describes? It describes the spatial distribution of the electron cloud. Okay. And also the angular momentum of the electron. So I'm writing it down over here. It describes the spatial distribution of electron cloud and also the angular momentum of the electron. Clear? It actually also tells us about the shape of the orbital occupied by the electron. Tells about the shape of the electron, shape of the orbital occupied by the electron. Right? For any given value of n, always remember the azimuthal quantum number can have all integral values which range from 0 to n minus 1, and each value will correspond to the subshell. Clear? So let me explain this point to you with the help of a small table over here so that things are a little more clear. So if I make this table divided into 3. So this is n, that is the principal quantum number. Here I am going to mention all the azimuthal quantum numbers, and here I am going to talk about the subshell notation. Okay. So let's begin. If n is 1, then what is L? It is 0. Then what are the subshell notations? It will be 1s. Okay. If n is 2, then what will be the azimuthal quantum numbers? It will be 0 and 1. And what will be the subshell notations? It will be 2s, because it is present in the second shell. So 2s, 2p. Then come to the third shell. Third shell means the azimuthal quantum number will be 0, 1, 2. Corresponds to this. Okay. Then what will be the subshells? It will be 2s, 3p, 3d. I hope you are following this. Then let me take 4 and 5, and that is enough for you to understand. Okay, so if it is 4, then what will be the azimuthal quantum numbers? With 0, 1, 2 and 3. So what will be the subshell notation? It is the fourth subshell. So 4s, 4p, 4d and 4f. Now coming to the fifth principal quantum number, then L will be how much? 0, 1, 2, 3 and 4. So what will be the subshell notation over here? Since we are talking about the fifth shell, therefore it becomes 5s, 5p, 5d and 5f. Clear? I hope now it's very clear to you. Okay, the next important point about azimuthal quantum number is the energy of the various subshells in the same shell increases in the order of S, P, D and then lastly is the F. So the energy of the various subshells in the same shell increases in the order of S and then P, D, and lastly F. Okay. Then next point, what do we know about the magnitude of the angular momentum? The magnitude of the angular momentum of an electron in an orbital, it is always given with the formula that I'll write over here. First, let me mention the magnitude of the angular momentum of an electron in the orbital. It is given by what? It is given by angular momentum mvr. This is equal to h upon 2 pi l plus 1. Okay, this is very important to be learned. Where your S subshell, then your L will be 0 angular momentum. If it is a P subshell, then your angular momentum will be equal to h under root 2 upon 2 pi. Okay, so for subshell S, L will be equal to 0 angular momentum. But if for subshell P, L is equal to 1 and the angular momentum is equal to what? It will be equal to h under root 2 upon 2 pi. Okay, so what does that mean? That it means that the angular momentum does not depend upon the value of n. Thus the 2p and 3p, 4p, all these electrons will have the same angular momentum, right? Now, number of times you must have heard me speaking S, P, D and F. So what are these? These are the spectral terms, right? These are spectral terms. What? For example, your S signifies sharp. Okay, your P signifies principal. Then your D signifies diffused. F means fundamental. Okay, so the maximum number of electrons that can be accommodated in this S, P, D and F subshell. How much? S can accommodate how many electrons? Only 2. P can accommodate 6. Okay, then D can accommodate how much? And F can accommodate only, D can accommodate 10 and F can accommodate how many? 14 electrons. Okay, this quantum number also helps to explain the 5 lines of the spectra. So I mention over here, this quantum number helps to explain the 5 lines of the spectrum. Okay, so I hope azimuthal quantum number is also very clear to you. Now we stop over here, and tomorrow and on Monday I will come back to you with the magnetic orientation number and the spin numbers. Thank you.